All right, for conditional probability, this is a little different than compound probability. So conditional probability says, what is the probability of one event given that another event has already occurred? So let me kind of give you an example of this to kind of see why this formula is the way it is before I give you the formula. So let's say you have a group of people and you want to know what's the probability that someone has green eyes given that they are a male. So in that case, you would have to say, well, I'm considering only the males with green eyes out of all the males in the group. So the formula for conditional probability is what's the probability of both events, A and B, out of just the probability that B has already happened. Let's just do a few examples using the same idea of the fair die, and then we'll do some examples with a different scenario. So just a couple examples with the fair die. What's the probability of rolling a 3 given that the number you rolled is odd? So the probability of rolling a 3 and that it is odd out of just the probability of rolling an odd. Okay, so kind of think of it as what's the probability of rolling a 3 given that it's odd? Well, what's the probability that you roll an odd number? So just out of all the possibilities for rolling an odd number, how many of those would also be a 3? So the probability of rolling an odd would be 1, 3, and 5. So there are 3 possibilities for rolling an odd number. But how many of those are the number 3 and odd? It's just 1, because only one of those numbers on the number cube or on the dice, only one of those faces has the odd number 3. So you have a 1 in 3 chance of rolling a 3 given that the number you rolled was an odd number. So again, you can write that as 0.33, or you can write that as 33.3%. Okay, let's do another one. What's the probability of rolling a 4 given that the number you rolled was less than 5? So the probability of getting the number 4 and being less than 5 out of just the probability of rolling less than 5. So I'm going to use the less than symbol. Less than 5. Right, so how many of the options in a die, how many of those are numbers that are less than 5? So that would be 1, 2, 3, and 4. So there are 4 faces on the dice that are less than 5. How many of those are also the number 4? Well, only one of them. So you have a 1 in 4 chance, or 25%. So I kind of think of it in this way. Of the odd numbers in a dice, how many of them are also a 3? Of the numbers that are less than 5 on a dice, how many of them are also the number 4? Right, so the probability of A given that B has already occurred. So remember, that's the probability of A and B out of just the probability of B. So again, think of it this way. Of the probability of a B happening, how many of those are also A? Right, so out of the probability of B happening, how many of those are also A? So they're A and B. All right, well, A and B is 0.25. We were given that information. And probability of B is 0.4. So really what this is telling us is that 40% of the time B occurs, and only 25% of the time A also occurs with B. So in this case, what we would do is we would use your calculator to divide 0.25 divided by 0.4, and you get 0.625. And you could leave it as this decimal, or you could change it to a percentage. So that would be 62.5%. Okay, let's try this other one. Now notice that the placement of the letters matters. So again, this is the probability of A and B out of just the probability of A. So this reads, given that A has already happened, how many of those were also B? Probability of A and B was 0.25. The probability of A was 0.7. So again, we will divide 0.25 divided by 0.7, and we get 0.357. I would round that to 3 decimal places, so 0.357. And you can change that to a decimal or a percentage. Either one is acceptable. Examples 3 and 4, I just want to point out that you should be very aware of the second letter because that's the one that goes on the bottom. Okay, so see how I have it highlighted here, the probability of A given B. Whatever letter comes second, that's the one that goes on the bottom. And the probability of B given A, that one goes on the bottom. So just be aware of that, but you can always think of it as out of B, how many were also A, or out of A, how many were also B.